Good morning, sixth graders. We're going to go ahead and take a look at calculating the volume of prisms. And tomorrow we will do the volume of cylinders. So volume is how much space is in the inside of an object. So the past two lessons we've been talking about surface area, which deals with the surface of a prism. This is a rectangular prism I have here. And volume deals with what we can fit inside of the three-dimensional figure. So for instance, like with a tissue box, the volume would be how many tissues you can physically fit inside of the tissue box, and the surface area would be, maybe how much wrapping paper you would need to wrap up a tissue box to give somebody as a gift. Not sure why you'd want to do that, but that's what it would be. Okay, so let's talk about calculating the volume of prisms. It's pretty straightforward, but let's recall that volume is the amount of space inside a three-dimensional figure. For instance, the amount of water a water bottle can hold is another example of volume. Volume is measured in cubic units, and we will take a look why that happens. The volume of prisms are calculated by multiplying the area of the base by the height of the prism. And the height connects, I want you to write this down, that the height connects the two bases together. Because some students have a hard time understanding what the height of the object would be, and I'll definitely demonstrate that in some of these examples, but please know the height is what connects the two identical tops and bottoms. Okay, so in general, volume is equal to capital B times capital H, where B is the area, of the base shape, and H is the height of the prism. So that's pretty much in general with prisms. So even if I gave you, let's say a prism where it had a trapezoid top and bottom, you would find the area of the trapezoid base, just one of them, and then multiply it by the height of the prism. Okay, so let's take a look at two of our most traditional examples, rectangular prisms and triangular prisms. So the base shape is a rectangle, and let's write that out. It's a rectangle right here. So this is our base shape, 3x4 rectangle, and the area of a rectangle is length times width. So when we find this volume, we're going to take this area of the base shape, which is length times width, and we're going to multiply it by the height. So that's how we get length times width times height. Okay, you learned that last year. It's going to be different for these different prisms I'm going to throw at you, like the triangular prism. This only works for rectangular prisms. So let's do an example here. So if I want to know the volume, we're going to do the trifecta, okay? Write the formula first, length times width times height. So this is going to be 4 feet times 3 feet times 8 feet. Okay, 4 times 3 is 12, and 12 times 8 is 96. And this is why we end up having, cubic units, because we have feet times feet times feet. Anything times itself 3 times gives you feet to the third power, or that thing to the third power. This is going to be very important that you include the cubic unit, otherwise I will be deducting points. Volume is not measured in square units, it's measured in cubic units. And what that means is what we're figuring out is how many of these 1 foot by 1 foot by 1 foot cubes we can actually fit into this entire shape. But pretend I'm drawing like three-dimensional little cubes. So that's what it means, is if we had a cube, and this is almost like a cube. If I cut this, down in half, I think it would probably be a cube. So if this were 1 foot by 1 foot by 1 foot, that would be a cube. And I'm saying how many times that will fit inside of this bigger rectangular prism. And it turns out that 96 of them can fit in. Let's take a look at the triangular prism. Okay, the triangular prism, the base shape is indeed a triangle. Okay, so that's your base shape, triangle. And the area of a triangle is 1/2 times base times height. So you will take this area of the base shape. So we're gonna find the area of this base shape and we will multiply it by the height of the prism. And the height of the prism connects the two top and bottom bases. So your height is 10 of the prism. And then your height of your triangle, you have to be very careful figuring out that component. So let me just write this out. So this little h is the height of the triangle, and the big H is the height of the entire prism. So please be careful, those are two different H's, so that's why we will leave that capitalized to differentiate it from the lowercase one. So first step, write the formula. So the volume is going to be the area of the triangle times the height. So this will be 1/2 times base times height times the height of the prism. And now we substitute in what we know. So this is gonna be 1/2. Remember, the base and the height of the triangle has to be perpendicular. So the base and the height are 15 and 20. It's 15 here and 20 here. It's not 25 because 25 is that slanted part and 25 is not perpendicular to anything in this case. So it's 15 and 20 times 15 yards times 20 yards times 10 yards. So remember that height of the prism is 10 yards. So now let's go ahead and multiply. Let's see, this is, well, half of 20 is 10. 10 times 10 is 100. 100 times 15 is 1,500 yards. 1, 2, 3. Yards times yards times yards gives you cubic yards, yards to the third power. So we would be able to fit into this big triangular prism if we had a cube that actually would be very big. That's a yard by a yard by a yard. You would be able to fit 1,500 of them into this triangular prism. All right, let's do a couple more examples together and then I'll let you finish the rest on your own and check the answer key on the website. I have another triangular prism here. As you can see, I have a triangle here and back here. So your bases are the two identical shapes, okay? It's not going to be all of these rectangles surrounding the prism. It is the two identical shapes. So this is a triangular prism. So the volume is going to be the area of the triangle times the height of the prism. The area of the triangle in this case, well, we always know is 1/2 times base times height. So this is 1/2 times 3.5 times 2. And the height of the entire prism, the height connects the two identical shapes. This is your height right here, because it is connecting the two identical triangles. So this is going to be times 4.2. Kelsey. All right, so we have 1/2 times 2 is 1 times 3.5 times 4.2. Just for the sake of the length of this video, I'm gonna go ahead and number crunch on a calculator real quick. 3.5 times 4.2, and we get 14.7. We are dealing with feet, and since this is volume, it will be to the third power, cubic feet. All right, and the last example, another rectangular prism. Rectangular prisms are even easier. The volume is going to be the area of the rectangle times the height, and we know the area of the rectangle is length times width times height. So this is going to be 10 yards times 12 yards times 15 yards. And that's 120 times 15 gives us 1,800 yards to the third power, cubic yards. I want you to go ahead and try the last 4 examples on your own and check the website for the answer key.